Hi guys, and welcome back to another episode where we will be solving the poorly answered questions from the 0625 Physics IGCSE syllabus for you. So we're continuing with the 2017 May-June paper 2-2, and we're looking at question 19 today. So this was apparently very challenging for students around the world, so let's read through the question first as usual. Different waves hit barriers with different sized gaps. The waves will diffract. In which diagram does the greatest spreading occur? Okay, so we know that first of all, the greatest spreading or the most diffraction will depend on the width of the barrier. So that means the smallest width is going to lead to the most diffraction. So as you can see, I can already eliminate two options, which are options C and D, because we've got 2 centimeters over here and we've got another 2 centimeters over here. Now, the second thing which students often forget is that it also depends on the wavelength lambda. So if you maybe remember your teacher discussing this in class, you know that you will get the most diffraction when the width of the barrier is comparable to the wavelength of the waves. So for example, with light, you tend to see the diffraction of light on a foggy night near lampposts. Why? Because the distance between the water droplets is comparable to the wavelength of light. That's why that's one of the situations where we can actually see the diffraction of light. So therefore, if I look at A and B, the wavelength in A is 1 centimeter and the width of the barrier is 2 centimeters. So as you can see, they're comparable, but they are not quite like situation B, where the width of the barrier is 2 centimeters, but the wavelength is also 2 centimeters. So they're exactly the same. So when they are comparable to each other, or in this case exactly the same as each other, this leads to the most amount of diffraction as well. Therefore, option B is the correct answer in this case. What students forgot in this question is that not only does diffraction depend on width, but it also depends on the wavelength. If the wavelength is the same or comparable, then that means that diffraction effects will be more apparent, meaning that there will be more spreading visible. Or in the case of sound, you'll be able to hear more sound, if you're standing in that particular room where sound is diffracting into. Alright guys, so take care. We'll be back again with another poorly answered question very soon. Good luck. Bye bye.